this video, we will continue with parametric differentiation. You will find this on page 506 in the Namibian AS-Level Mathematics textbook, y equals mx+c to success. Let's look at another example. The parametric equations of a curve are x is equal to 1 minus e to the power negative t, y equals e to the power t plus e to the power negative t. Find the exact value of t at the point on the curve at which the gradient is 2. Okay, so first we're going to differentiate both. So if we differentiate this one, because it's just 1, it stays, but this is negative 1, so the negative 1 goes in front, but it stays then. I simplify. This one, dx over dt, so this will not, okay, it becomes 0, and then this one, the negative in front, okay, but don't forget that negative was also there. That's why I put a bracket. So there's the negative 1 from the exponent, and I just rewrite. And basically, a negative, it's positive, but if it's like this. And now if I swap it around, I always swap the x1 around, then it will become this. Okay, so I just want to make it a bit bigger. This exponent is too small for me. Okay, so basically, can I just show you? So as soon I could have wrote it there. So this one was dx over dt, and then because I'm swapping both sides, I'm not taking it up, I'm swapping it around, then it becomes like this, basically just the reciprocal of that. Okay, and then I'm going to multiply. So I multiply this 2 and I get this. Okay, don't negative t plus t, that's why it's 0, and that becomes 1. Don't forget that one. Okay, so when the gradient is 2, I put this dy over dx equals to 2, so I put this equals to 2. So if I take it over, that is 3. And now I go from exponential form to logarithmic form. And remember e, I always go for ln. So it's ln, and remember the base is e, and I just swap this 2 sides. Okay, and then if I swap the 2 sides, I'm basically getting, okay, e, let's rather say I swap this 2 sides. That's better showed. Okay, so it's ln 3, and the e is there at the bottom, and then to t, and I want t, so I divide 3. And I leave it like this. I don't use a calculator, and I just want to see if they say the exact. Find the exact. Usually if they say find the exact value, then it means leave it like that. Don't approximate it. Don't press it on the calculator, because that would be approximated value. So exact, do not calculate, leave it like that. Okay, I want you to stop the video, and I want you to do number 1. Again, you can continue the video as soon as you are finished. I see in the previous video, or one of the videos, it was 35, and then actually it was 36. But it doesn't matter. You can see it's just this one that I'm going to do. Number 1. Okay, let's start. A parametric equations of a curve are, and then it's x is equal to 3t plus ln t minus 1. And then y is equal to t squared plus 1. This is very important. I'll come back to that at the end. And then t is bigger than 1. Okay. So let's start and then find the coordinates of the only point on the curve in which the gradient of the curve is equal to 1. And it's due to that it makes it only 1. Okay, but let's first start. Now, if you as soon as you come to something like that and it looks a little bit more complicated, the best is to go for the chain rule. So I'm basically making this thing, okay, okay, so you don't have to do it in so much detail. You can just say, okay, on the side, it's actually better the side that I'm doing now, but it's actually ln u, and u is equal to t minus 1. So let's call it y, doesn't matter. So it's dy over du, it's 1 over u, and du over dt is equal just to 1. And if I multiply this, I get dy over dx and it's just 1 over u, so it's going to be 1 over, and what is u? Don't forget, that's u, t minus 1. Okay, so for that part, I don't want to write the u there, just want to clean it there. Okay, so basically you can do it on the side and then just bring your final answer in, then otherwise it becomes a little bit messy. So, okay, now you can say dx over dt. So let's first differentiate this term. It's just 3. And then I showed you this one. So it's plus 1 over t minus 1. Now, usually we don't like 2 terms. We want 1. So put it over 1. Make it like that. Make your denominators the same. So I multiply t minus 1 and on top also t minus 1. Okay. So what do I get? I get 3 t minus 1, okay, plus 1 over t minus 1. Okay, and that's 3t minus 3 plus 1. Let's just get the pen correct. Plus 1 over t minus 1. So it's 3t minus 2 over t minus 1. I'll show you now when I'm going to turn it around. But for now, I think let's first stop there and then I'll continue. If you do something at here, then just at least draw a line that it's a little bit more clear. Okay. So then this one, it's going to be dy, oh this is nice, over dt, and it's just 2t. Okay, and now I have to swap this one around. So it's going to be always the x1, dt over dx. And it's going to be t minus 1 and 3t minus 2. Okay. Okay, let's just continue. So then, now I'm going to have, I just want to keep it a little bit lower. Now I want to have dy over dx equals 2t multiply t minus 1, 3t minus 2. Let's just do that. Equals, and then that will be 2t squared minus 2t over 3t minus 2. Okay, now if, and let's just go there, find the gradient on the point of the curve at which the gradient of the curve is equal to 1. So when the gradient, let's just say, when the gradient is 1, then dy over dx is equal to 1. That's basically what's happening. So in the place of dy over dx, I'm just going to put a 1. And then I have 2t squared minus 2t over 3t minus 2. I put it over 1. I cross multiply. So I have 2t squared minus 2t equals 3t minus 2. Okay. Then I'm taking everything to one side. So 2t squared minus 2t minus 3t plus 2 equals 0. And that's 2t squared minus 5t plus 2 equals 0. Okay, I factorize 2, 1, 1, 2 because it's in group A, positive. So it's 4 plus 1, it's at 5. Signs are the same, both is negative. Okay, and t. So let's just continue that bracket. So I have 2t minus 1 and t minus 2, and that is equal to 0. So therefore, 2t is equal to 1 or t is equal to 2. So t is equal to a half or t is equal to 2. But now, and always read your question again. And then you will see that. Can you remember on top we said t must be bigger than 1. Can I show you here? I underline it. T must be bigger than 1. So, therefore, you can just say, therefore, t bigger than 1, so t is equal to 2. That is your final answer.